Hi everyone, how are you? Welcome back Murari Maths online classes. Today we discuss about matrices Jeemains previous year questions. So now explain next question. If A and B are two square matrices of size n by n such that A square minus B square is here one condition given A square minus B square is equal to A minus B into A plus B. Which of the following will always be true? If this condition is satisfied, when AB is equal to BA or A is equal to B, here third option either A or B is a zero matrix, either A or B is an identity matrix. First write A square minus B square. First we should multiply these two matrices. Here A multiplied to all, what we get here A square plus AB. Then after multiply minus B to all, minus BA minus B square. Here both side one A square as well as one B square cancelled. Minus BA sending right side, what we get here plus BA. BA is equal to AB. If this condition, if AB is equal to BA, then what is the formula? A square minus B square is equal to A minus B into A plus B. A minus B into A plus B. So option 2 correct. Okay, now explain next question. Here A matrix given as well as one condition A inverse is equal to alpha I plus beta A, where I is 2 by 2 identity matrix, then find out 4 times of alpha minus beta. 4 times of alpha minus beta. How to solve? First given condition right here. A inverse is equal to alpha I plus beta A. Now we should multiply first A inverse on both A on both sides. Multiply A on both sides. What we get here? A into A inverse is equal to alpha into A into I plus beta into A into S, A into A. A into A inverse, we get identity matrix I. Alpha into A into I. A into I is nothing but A. Beta into A into A is nothing but beta into A square. Here, first we have to find A square value. A square is nothing but A into A. So what is A into A here? What from statement A matrix is given 1 2 minus 1 4 into 1 2 minus 1 4. Now do multiply here. First row multiply with first column. What we get here? 1 into 1 here minus 1. First row second column 10. Second row first column we get minus 5. Second row second column minus 2 plus 16 14. This is A square value. Now direct substitute here 1 0 0 1. Your identity matrix is equal alpha times of 1 2 minus 1 4 plus beta into A square value minus 1 10 minus 5 14. Here now 1 0 0 1 is equal to alpha multiplied to all alpha 2 alpha minus alpha 4 alpha, as well as here beta multiplied to all minus beta 10 beta minus 5 beta 14 beta. So what we get here, sum of these two matrices we get alpha minus beta 2 alpha plus 10 beta, here minus alpha minus 5 beta, here 4 alpha plus 14 beta. Okay, now these two matrices are equal matrices. Now equating corresponding elements, what we get here? Alpha minus beta is equal to 1. Here alpha minus beta value we get 1 here. Therefore, alpha minus beta is equal to 1. What is required here? From statement required is 4 times of alpha minus beta. 4 times of alpha minus beta is equal to 4 times of 1 is equal to how much answer? 4. Okay, now I am going to explain next question. Here A is equal to Aij given matrix be a real matrix of order 3 by 3. A 3 by 3 matrix is given. One more condition here given. What is the condition? AI1 AI1 plus AI2 plus AI3 is equal to 1. What is required? The sum of all entries of the matrix AQ. First find out A matrix. A matrix is nothing but A11, A12, A13, A21, A22, A23, A31, A32, A33. This is 3 by 3 square matrix. From statements AI1 plus AI2 plus AI3 is equal to 1. For I is equal to 1, 2, 3. Let us take I is equal to 1 here. What we get here? A11. No? I plus 1 right here. Here I plus 1 right. A12 plus A13 is equal to 1. Let us take I is here. I is equal to 1. Let us take I is equal to 2. What we get here? I plus 2 substitute here. A21, A22, A23 is equal to 1. Let us take I is equal to 3. A31 plus A32 plus A33 is equal to 1. So A11 plus A12, A11 plus A12 plus A13 is equal to 1. A21 plus A22 plus A23 is equal to 1. A31 plus A32 plus A33 is equal to 1. Here, only possible condition A11 is, let us take 1 now. Here 0, 0. 1 plus 0 plus 0, 1. Here A22, let us take 1 now. Here 0, 0. 0 plus 1 plus 0, 0. A33, we should take 1 now. Remaining 0, 0. Okay, here principal diagonal elements we should take once. So this condition satisfied. What is this condition? Given condition is satisfied. So principal diagonal elements are equal to once. Given condition is satisfied. So 1, 0, 0, 0, 1, 0, 0, 0, 1. So what is required here? Sum of all entries of the matrix AQ. Sum of all elements. The required is the sum of all elements. The required is sum of all elements is equal to sum of all elements. So 1 plus 0 plus 1 plus 1 plus 1 is nothing but 3. Answer is 3. Okay, now I am going to explain. Here A matrix is given. Matrix A given. A into A transpose is equal to unit matrix given. Then find out A to the power 4 alpha to the power 4 plus beta to the power 4. So what is given condition? A into A transpose is equal to I, unit matrix. What is A? Given matrix is A. What is A given? 1 minus alpha, alpha, beta into 1 minus alpha, alpha, beta is equal to unit matrix is 1, 0, 0, 1. From this condition, we have to find first alpha, beta values. Condition. First do multiplication. Here, first row multiply with first column. What we get here? First row, first column 1 plus minus alpha square. Here, first row, first column. 1 minus alpha, alpha, beta, 1 minus alpha, alpha, beta. Here A transpose. Hi everyone, how are you? Welcome back Murari Maths online classes. Today we discuss about matrices Jeemains previous year questions. Okay, now I am going to explain next question. If omega not equal to 1 is complex cube root of unity, then Here one from statement H value given, H is equal to omega 0, 0 omega, then find out H to the power 70. So how to compute H to the power 70? First we have to find H square value. H square is nothing but H into H is equal to omega 0, 0 omega into omega 0, 0 omega. It will becomes, now we should multiply first row with all columns. So omega into omega, omega square 0. Okay, omega next element is 0, next is 0 omega square. So H square we get omega square 0 omega square. Okay, next similarly we have to find H cube. H cube is nothing but H into H square. The H from statement omega 0, 0 omega given. H square value is omega square 0, 0 omega square. Now we should multiply 2 by 2 matrices. Here first row multiply to first column as well as second column. First row multiply with first column, what we get omega cube. First row multiply with the second column is 0. Next is 0 omega cube. Okay, H cube is equal to omega cube 0 omega cube. So similarly H to the power 70 is equal to H to the power 70 is equal to omega power 70 0 0 omega power 70. Okay, we have omega power 70 is equal to omega power 69 into omega. Omega cube value we have 1. Omega power 69 is also 1. So omega power 69 can be written as omega cube power 23. So omega cube power 23 is nothing but omega power 69. So omega cube into omega. Omega cube value we have 1. 1 to the power 23 into omega. What we get here? Omega. So omega power 70 is nothing but omega. Omega 0, 0 omega. Okay, here omega 0, 0 omega is nothing but H. What is the answer here? H. Okay, now I am going to explain. Next question. Here, in a statement, A is 3 by 3 non-singular matrix given, as well as one condition is given, A dash into A is equal to A into A dash, where A dash indicate transpose of A, as well as one B matrix given, B is equal to A inverse into A dash. Then find out B dash. Okay, first we have to find B into B dash. So B dash is transpose of B. So what is B here given? A inverse into A dash into B. Again write B whole dash. A inverse into A dash whole dash. Okay, we have one formula AB whole dash is equal to B dash A dash. Okay, here A inverse into A dash into A inverse into A inverse A dash whole dash is nothing but A dash whole dash into A inverse whole dash according to this property. So A inverse into A dash whole dash is nothing but A. Double transpose is equal to itself. A dash whole dash is equal to A. A inverse whole dash. So here A inverse into A dash into A. Here A dash into A from statement this is given. A dash into A is equal, what is given? A into A dash given. So A dash into A place and write A into A dash into A inverse whole dash. A inverse into A value, how much value? A inverse into A is equal to unit matrix I. I into A dash into A inverse whole dash is nothing but, according to this property, we should write A inverse A whole dash. A inverse A whole dash. A inverse A whole dash. So I into any matrix is same matrix. A inverse into A is nothing but I whole dash is nothing but I. What is the answer here? Unit matrix I. Here B dash A dash value AB whole dash. Here A dash into A inverse whole dash is nothing but A inverse into A whole dash. Here X dash into Y dash is equal, what is the formula? Yx whole dash. Here expression A, Y relation A dash there here. Now we should apply this property Yx whole dash. Yx means Y relation here A inverse A whole dash. So A inverse into A is nothing but unit matrix I. By using this is inverse property. Okay, now explain next question. If you have matrix A 1 minus alpha, alpha, beta, here one more condition A into A transpose is equal to I2. I2 means 2 by 2 unit matrix. Then the value of alpha to the power 4 plus beta to the power 4. So from statement, what is given? A matrix is given 1 minus alpha, alpha, beta. First, we have to find a transpose of A. Transpose of A is nothing but by changing its rows into columns or columns into rows, what we get here? First column here will be right to first row 1 alpha minus alpha beta. This is transpose of the given matrix. So here, given that A into A transpose is equal to I. So A here 1 minus alpha, alpha beta into transpose of A. Transpose of A is, we have got 1 alpha minus alpha beta is equal to unit matrix is 1 0 0 1. Okay, now we should multiply 2 by 2 matrices. Here first row multiply with first column, what we get here 1 plus alpha square. 1 into 1, 1 minus alpha into minus alpha plus alpha square. So first row multiply with second column, alpha minus alpha beta. So now we should take second row multiply with first column, what we get alpha minus alpha beta. And the second row multiply with second column, alpha square plus beta square is equal to unit matrix 1 0 0 1. Okay, let us observe these two matrices. These two matrices are equal matrices. So equal matrices means there are equating corresponding elements. What we get here, 1 plus alpha square is equal to 1. Here 1 get cancelled, alpha value we get 0. Okay, next A12 element, next element alpha into 1 minus beta here is equal to 0. So here 1 alpha into 1 minus beta is equal to 0. 1 minus beta is equal to 0. Beta we get 1. So beta is equal to 1, alpha is equal to 0. Now what is required here? Alpha to the power 4 plus beta to the power 4. Here 0 to the power 4 plus 1 to the power 4, it will be 1. What is the answer here? 1. Okay, now I am going to explain next question. In the statement matrix A given, the system of linear equations A to the power 8 into column matrix xy is equal to 864. The system has how many 4 options are given? Unique solution, infinite many solution, no solutions, exactly 2 solutions. First we have to find A to the power 8. How to find A to the power 8? A to the power 8 is nothing but A to the power 4 into A to the power 4. So now here A to the power 4 can be written as A square into A square. Here A square can be written as A into A. First find out A square value. Here A value I minus I, where I is I value root minus 1 iota value. So I minus 1 minus I minus I into I minus I minus I. What we get here? So I is equal to root minus 1 I square, where we get minus 1 iota value. Iota whole square is equal to minus 1. Okay, now we should multiply these two matrices. What we get here? First row multiply with first column I into I square minus 1. The minus I into minus I plus I square, it is also minus 1, minus 1, minus 1. Next here minus I square, here minus I square. Next, second row multiply with first column, what we get? Minus I square, minus I square. Second row multiply with the second column, I square plus I square. So it will going to be minus 2. I square value minus 1. Here plus 1, this is 2. Here I square value minus 1. Minus I square value plus 1. Here minus I square value plus 1. Plus 1 plus 1 we get plus 2. Here also plus 2. I square value minus 1. Minus 1 what we get here? Minus 2. So A square value minus 2 plus 2. 2 minus 2. That implies A to the power 4. A to the power 4 can be written as A square into A square. What we get here? Minus 2 plus 2. 2 minus 2. Right? 2 times. Minus 2, 2, 2 minus 2. Now I say that here, again multiply these two matrices. What we get here? First row multiply with first column minus 4. Minus 2 into minus 2 plus 2 plus 4 plus 4 plus 4 8. Next element minus 8. Next element minus 8 plus 8. So A to the power 4 is equal to 8 minus 8 minus 8 plus 8. Okay, now find out A to the power 8. A to the power 8 can be written as A to the power 4 into A to the power 4. A to the power 4 value we have got 8 minus 8 minus 8 plus 8 into 8 minus 8 minus 8 plus 8. What we get here? After multiplication we get 128 minus 128 minus 128 plus 128. This is A to the power 8 value. Now from statement, what is given condition? A to the power 8 into, this is given, A to the power 8 into column matrix xy, column matrix xy is equal to 864. Column matrix 864. So A to the power 8 relation, write this value 128 minus 128 minus 128 plus 128 into xy is equal to 864. So now we should multiply these two matrices. First, the order of this matrix is 2 by 2, here 2 by 1. The number of columns in first matrix, the number of rows in second matrix, if is equal, the product is defined. So order of the resultant matrix is 2 by 1 is equal to 864. This is also 2 by 1 matrix. Here first row multiply with first column, what we get here? 128x. Next minus 128y. Here second row multiply with first column, what we get? Minus 128x plus 128y. Okay, now these two matrices are equal matrices. Now equating corresponding elements, what we get? 128x minus 128y is equal to 8. So both side 8 get cancelled. What we get here? X minus y is equal to 8 by 128. It will becomes 1 by 16. So let us take equation 1. Okay, now we should take next elements minus 128x minus 128x plus 128y is equal to 64. Now both sides get cancelled 64. So what we get here? X minus y is equal to minus 1 by 2. This is second equation. So first equation, second equation, two equation represents two lines. These two lines are parallel lines. So first equation, second equation, both equations are represents two straight lines. These two straight lines are parallel. So parallel means no point of intersections. No point of intersections. So no point of intersection means here the system has no solution. The system has no solution. The system has no solution. So this option is correct. So third option is correct. So let us observe here equation 1 slope is 1. No? Equation slope of equation 2 is also 1. So these two lines are parallel. So those parallel lines are not intersecting. So Answer is no point of intersection of equation 1 and equation 2. So answer is solutions are not there. So answer is no solution. Option is correct. Okay, now explain next question. In the statement A is symmetric matrix, B is skew symmetric matrix are given, and also one condition A plus B is equal to 2, 3, 5 minus 1, one square matrix is given, then find out AB value. So what is the what is here A? A is a symmetric matrix, B is a skew symmetric matrix. One property is there, any square matrix can be expressed as sum of symmetric and skew symmetric matrix. Here, let us take given square matrix is X. X is equal to 2, 3, 5 minus 1. Therefore, A plus B is equal to X. Here, what is A here? A is the symmetric matrix. Okay, we have symmetric matrix formula is X plus X dash by 2. So, B is the skew symmetric matrix. This formula is X minus X dash by 2. It will going to be 1 by 2 times of 1 by 2 times of A plus X dash by 2. Your X value, how much value here? 2, 3, 5 minus 1 plus this transpose value 2, 5, 3 minus 1. What we get here? 1 by 2 times of sum of these two matrices 4, 8, 8 minus 2. It will becomes 2, 4, 4 minus 1. This is symmetric matrix value. Skew symmetric matrix value 1 by 2 times of take difference here. What is X here? 2, 3, 5 minus 1. This is X. So transpose of X is 2, 5, 3 minus 1. Take difference. What we get here? 1 by 2 times of 0 minus 2, 2, 0. So 1 by 2 multiplied to all. What we get here? 0 minus 1, 1, 0. So what is required here? Required is AB. AB is equal to A matrix. We have got it 2, 4, 4 minus 1 into B matrix also 0 minus 1, 1, 0. Here product of these two matrices we get first row multiply with first column. What we get here? 4. First row multiply with the second column minus 2. Second row multiply with first column minus 1. Second row multiply with second column. What we get here? Minus 4. What is the answer? 4 minus 2 minus 1 minus 4. Okay, now explain next question. Here in the statement matrix A given as well as A to the power 32 value 0 minus 1, 1, 0 given. Then find out the value of alpha. A to the first find out A to the power 32 value. First find out A square value. A square is equal to A into A. What we get here? A value cos alpha minus sin alpha. Sin alpha cos alpha into cos alpha minus sin alpha. Sin alpha cos alpha. Now we should multiply these two matrices. First row multiply with first column. What we get here? First row having cos alpha minus sin alpha. Here first column having cos alpha sin alpha. What we get here? Cos square alpha minus sin square alpha is cos 2 alpha. So we have some formula cos square alpha minus sin square alpha is equal to cos 2 alpha. Cos square alpha plus sin square alpha is equal to 1. So first row multiply with first column cos 2 alpha and first row multiply with the second column minus cos alpha sin alpha minus sin alpha cos alpha minus sin 2 alpha. Okay, 2 sin alpha cos alpha we get formula is sin 2 alpha. Next second row multiply with first column sin alpha cos alpha sin alpha 2 cos alpha sin alpha is nothing but sin 2 alpha. Here next one is sin is minus sin square alpha plus cos square alpha is cos 2 alpha. So a square value is cos 2 alpha minus sin 2 alpha, sin 2 alpha, cos 2 alpha. Similarly, a to the power 32 value cos 32 alpha minus sin 32 alpha, sin 32 alpha, cos 32 alpha. But here what is given? 0, minus 1, 1, 0 given. Now these two matrices are equal matrices. Now equating corresponding elements. Here cos 3 to cos 32 alpha is equal to 0. Okay, we have one sin here, sin 32 minus sin 32 alpha is equal to minus 1. Sin 32 alpha value, how much value? Plus 1. So therefore, sin 32 alpha is equal to 1. Cos 32 alpha is equal to 0. Now dividing these two values, sin by cos we get tan 32 alpha is equal to 1 by 0 is nothing but 1 by 0 is nothing but infinite. So is nothing but tan 90 degrees. So tan 32 alpha is equal tan pi by 2. Okay, we have one formula. Tan theta is equal to tan alpha. Theta we get n pi plus alpha, n belongs to z. Here alpha place in pi by 2, theta place in 32 alpha, right in formula. So 32 alpha is equal to n pi plus pi by 2, where n belongs to z. So put n is equal to 0. What we get? 32 alpha is equal to pi by 2. Alpha is equal to pi by 64. This 32 sending right side is divide pi by 64. One of the option this is. Alpha is equal to pi by 64. Okay, now explain next question. Alpha be the root of this given equation x square plus x plus 1 is equal to 0. And also one A matrix is given. Then find out a to the power 31. Okay, here alpha is the one of the root. Alpha is the one of the root of x square plus x plus 1 is equal to 0. Now alpha satisfied in given equation. Alpha square plus alpha plus 1 is equal to 0. Okay, here alpha values are minus 1 plus or minus square root of b square minus 4ac by 2a. b square minus 4ac by 2a. It will become minus 1 plus or minus root 3i by 2 is nothing but omega square. Here omega value minus 1 plus root 3i by 2. Omega square value minus 1 minus root 3i by 2. So alpha value, let us take omega. Omega is the cube root of unity. Okay, we have one properties 1 plus omega square is equal to 0. Omega cube is equal to 1. Okay, first what is required here? A to the power 31 is required. First we have to find a square value. A square is nothing but a into a. So a into a, how much value? 1 by root 3 times of 1, 1, 1. 1 here alpha place in right omega, 1 omega square, 1 omega square, omega to the power 4. Omega to the power 4 value, omega cube into omega, right? Omega cube is 1, 1 into omega is omega. Here into 1, 1, 1, 1 omega square, 1 omega square, omega to the power 4 is omega into 1 by root 3. This is a value. This is also a value. A into a is equal to a square. 1 by root 3 into 1 by root 3, what we get? 1 by 3. Okay, now we should multiply these two matrices. First row multiply with all columns. First row multiply with first column, what we get? 1 plus 1 plus 1, 3. First row multiply with the second column. 1 plus omega square 0. First row multiply with the third column, it is also 0. Second row multiply with first column, 1 omega square 0. Second row, second column, it will be 0. Second row, third column, 1 omega square, omega 1 into 1, 1. Omega into omega square, omega cube also 1. Omega square into omega 1. How much value? This is 3. Next third row multiply with first column is 1 omega square omega 0. Next 1 into 1 1 omega cube. This is 3, this is 0. So here I take 3 common in this matrix. 3 by 3 into 1 0 0 0 0 1 0 1 0. What we get here? 1 0 0 0 0 1 0 1 0. This is a square. So a square value, so we have got 1 0 0 0 0 1 0 1 0. Then after find a to the power 4. A to the power 4 can be written as a square into a square. So 1 0 0 0 0 1 0 1 0 into 1 0 0 0 0 1 0 1 0. What we get here? First row multiply with first column, we get 1. First row, second column, 0. Next 0. Second row, first column, 0. Second row, second column, 1. Next 0, 0, 0, 1. This is unit matrix. Therefore, a to the power 4 is equal to unit matrix I. So a to the power 4. But what is required? A to the power 31 is required. A to the power 31 can be written as a to the power 4 whole to the power 28 whole to the power 7. 7 4 is 28 into a cube. So a to the power 4 place and write I to the power 7 into a cube. So I to the power 7 value I. Here I to the power n is equal to I, where n belongs to any natural number. So I to the power 7 value I into a cube is equal to a cube. So what is the answer here? A cube is the answer. Okay, now I am going to explain next question. Here A matrix is given as well as a to the power 5 A, B, C, D also given, which of one of the following is not true. First we have to find a square, a to the power, then after a to the power 5. So a square value, how much value? A into a. Here a value cos theta, I sin theta, I sin theta, cos theta into, again write A matrix, cos theta, I sin theta, I sin theta, cos theta. What we get here? First row multiply with first column, cos square theta, I square value here minus 1, iota whole square. Cos square theta minus sin square theta, it will be cos 2 theta. And first row multiply with the second column, I cos theta sin theta, I cos theta sin theta, 2I sin theta cos theta. It will going to be I sin 2 theta. I sin 2 theta. Next element, second row, first column. This is also I sin 2 theta. The second row, second column, I square sin square theta is minus sin square, I square sin square theta. Here this is A22 plus cos square theta. I square value minus sin square theta plus cos square theta. Cos square theta minus sin square theta, we get cos 2 theta. So a square value cos 2 theta, I sin 2 theta, I sin 2 theta, cos 2 theta. So similar, a cube value is cos 3 theta. Similarly, cos 3 theta, I sin 3 theta, I sin 3 theta, cos 3 theta. Okay, therefore a to the power 5 value we get cos 5 theta, I sin 5 theta, I sin 5 theta, cos 5 theta is equal to a to the power 5 value from statement A, B, C, D given. Therefore, A, B, C, D, these two matrices are equal matrices. A value we get cos 5 theta, B value I sin 5 theta, C value also I sin 5 theta, D is equal to cos 5 theta. So therefore, A is equal to cos 5 theta, B is equal to I sin 5 theta, C is equal to I sin 5 theta, D is equal to cos 5 theta. A, B, C, D. Okay. So what are options are given? A square minus C square. First option. So let us take first option, A square minus C square. So A square minus C square value, how much value here we have got it? A square is cos square phi theta minus C square. C square means minus I square sin square phi theta. But I square value here minus 1. So cos square phi theta plus sin square phi theta. We get 1. So first option what is given here? A square plus A square minus C square is equal to 1. This is correct answer. But here what is the required? Which option is not true? So first option is correct. So option, let us take option 2. So option 2 here, A square minus D square given. A square minus D square. A square is cos square phi theta minus D square is cos square phi theta. Cos square phi theta, cos square phi theta get cancelled. What we get here? 0. 0. So here A square minus D square is equal to how much value? A square minus D square value is 0. But in statement is A square minus D square is equal to 1 given. A square minus D square is equal to 1 given. This is not correct. Next, A square minus B square value, how much value we have got it? A square minus B square is equal to here. Here from statement, this is 1 given. Okay, option number 3. A square minus B square. A value here cos square phi theta. B square value I square sin square phi theta. So this is A cos square phi theta plus sin square phi theta. We get 1. This is also correct answer. This is also correct answer. Next option number 4, A square plus B square find out. A square plus B square is equal to cos square phi theta plus B square is plus I square sin square phi theta. Okay, here cos square phi theta minus sin square phi theta. Cos square phi theta minus sin square phi theta is cos 2 theta formula, cos 2 into phi theta, it will going to be cos 10 theta. So cos 10 theta is always lies between 0 to 1. Why? Because theta is equal here. What value given? Pi by 24 given from statement. Theta is equal to pi by 24. Then cos 10 theta is 10 into theta plus and right pi by 24. So it will going to be, it is always lies between 0 to 1. So option 4 also correct. So option 2 is wrong. So which option is not true? Second option is not true. Okay, now I am going to explain next question. Here ABC belongs to any real numbers. Satisfying the equation A cube plus B cube plus C cube is equal to 2. So one matrix A given. This matrix satisfies A transpose into A is equal to I. Then the value ABC can be. In statement, what is given? A transpose into A is equal to I given. Where A cube plus B cube plus C cube is equal to how much value given here? 2 given. So A transpose. So A from statement A, ABC, PCA, CAB, A transpose, it is nothing but ABC, first column will be changed into first row, ABC, BCA, CAB. So now substitute here, ABC, BCA, CAB into here ABC, BCA, CAB is equal to unit matrix, right? 1 0 0 0 1 0 0 0 1. What we get here? Okay, let us do multiplication here. First row multiply with first column. What we get? First row multiply with first column. A square plus B square plus C square is equal, here element is 1. As first row multiply with the second column, AB plus BC plus CA is equal here 0. Okay, what is required here? One more condition also given, A cube plus B cube plus C cube is equal to 2. This is the given. Okay, we have one formula. A plus B plus C whole square is equal to A square plus B square plus C square plus 2 times of AB plus BC plus CA. So A square plus B square plus C square value 1. No? 2 times of AB plus BC plus CA 0. How much value here? A plus B plus C whole square is equal to 1. Here A plus B plus C whole square value, how much value? We have got it 1. Therefore, A plus B plus C is equal to plus or minus 1. But what is required here? ABC value required. So in statement, from statement, one more condition is given, A cube plus B cube plus C cube is equal to 2. Okay, we have one formula. A cube plus B cube plus C cube minus 3ABC is equal to A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA. A cube plus B cube plus C cube value from statement is value given. How much value? 2. Minus 3ABC. ABC value required is equal A plus B plus C value plus or minus 1. A square plus B square plus C square value from statement to this condition we have got it 0. This 0 minus of AB plus BC plus CA. This is also A square plus B square plus C square value 1. No? This is 1. No? AB plus BC plus CA value 0. What we get here? Plus or minus 1. So let us take first case plus case 1. 2 minus 3ABC is equal to 1. Here write case 2. 2 minus 3ABC is equal to minus 1. So 3ABC we get 1. ABC is equal to 1 by 3. Next here 3 is equal 3ABC. ABC we get 1. So both answers 1 and 1 by 3 both are correct. So in option 1 by 3 given. Okay, now explain. First question, A is equal to 1 0 0 1 1 0 1 1 1. B is equal to A to the power 20. What is required here? The sum of all the elements of the first column of the matrix B. First, we have to find A to the power 20. So A to the power 20, how to find? First, find out A square value. A into A. A into A, it will becomes, first write A matrix and A matrix. So after multiplication, we get here first row multiply with all columns. We get 1 0 0. Here second row multiply with all columns. We get 2 1 0. Here third row multiply with all columns. We get 3 2 1. Okay, similarly, we have to find A cube. A cube is equal to write A into A square. Here, A value from statement, this value given into A square value, we have got it. 1 0 0, 2 1 0, 3 2 1. After multiplication, we get 1 0 0. Here 3 1 0, 6 3 1. So let us observe here in A square matrix, second row first column, third row second column, 2. Here this is different. Third row first column element. In A cube matrix, second row first column, third row second column element is equal to 3. This third row First column element is different. So similarly, we have to find a to the power 4. A to the power 4 can be written as a square into a square. A square into a square, we get 100, 410, 1041. A to the power 5. A to the power 5 can be written as a into a to the power 4. A into a to the power 4. A matrix from statement given 100, 111, 110, 111 into a to the power 4 value, we have got it here. 100, 410, 1041. After multiplication, we get 100, 510, 1551. Okay, then after find out a to the power 10 value. A to the power 10 can be written as a to the power 5 into a to the power 5. 100, 1510, 1551 into, again write same matrix, 100, 1510, 1551. What we get here? First row multiply with all columns. 1, 0, 0. Next here, second row multiply with first column. 15 plus 15. Second row multiply with first column. 15 plus 15. Here a to the power 5 value, here 5, 5. Okay, second row multiply with all columns. What we get here? 5 plus 5, 10. 1, 0. Here this value, third row multiply with first column. 15 plus 25 plus 15, 55. 15, 0. Here 5, 5, 10, 1. Next, a to the power 20. A to the power 20 can be written as a to the power 10 into a to the power 10. A to the power 10, 100, 10, 10, 55, 10, 1 into 100, 10, 10, 55, 10, 1. What we get here? First row multiply with first column. 1, 0, 0. First row, first column, first row, second column, first row, third column. Next, second row multiply with all columns. 10 plus 10, 20. Here 1, 0. Third row multiply with first column. 2, 10, 21. This is equal. What is given here? B value given. A to the power 20 is equal to matrix B given. What is required? The sum of all elements of the first column of B. Here, first column having 1, 20, 210. 1 plus 20 plus 210 is this is required. Is equal to 231. Sum of all elements of first column of the matrix. First column of the matrix B is equal to 231 answer. Okay, now I am going to explain question of next question. Here A matrix as well as A square given. Then find the options. Here in statement A square is equal to A into A. This matrix given alpha, beta, beta, alpha is equal to A into A. If from statement A matrix is given AB, BA into AB, BA. Now do multiplication here. So 2 by 2 multiplication. First row multiply with all columns. What we get here? A square plus B square. Here AB plus BA 2AB. Here BA plus 2, BA plus AB is also 2AB, B square plus A square. Now these two are equal matrices. Now equating corresponding elements, alpha is equal to A square plus B square, beta is equal to 2AB. Which option is correct? First option is correct. Okay, now I'm going to explain. Next question. Here in the statement, AB are two square matrices of size n by n. One condition is A square minus B square is equal to A minus B into A plus B given. Then which of the following will always be true? So in statement A square minus B square is equal to what is given? A minus B into A plus B given. So A square minus B square is equal to A minus B into A plus B. First A multiplied to all. A into A square plus A into B AB. Next here minus B multiplied to all. Minus BA minus B square. So matrix multiplication is not satisfied commutative property. AB is not equal to BA here. Here A square both sides get cancelled as well as B square. So 0 is equal to AB minus BA. AB minus BA. So AB is equal to what we get here. AB is equal to BA. We have got it. So A square minus B square is equal to A minus B into A plus B. When will possible? Here matrix multiplication is satisfied. If satisfied associated commutative property, then A square minus B square, we have A minus B into A plus B. Otherwise, this condition is not satisfied. What is the answer here? AB is equal to BA. Thank you for watching. Remaining questions I will explain on next class.